Hey, how's it going? I wanted to make a quick tutorial today on how to simulate smokeless fire in Houdini 19.0 and how to render the fire so that it has, I'll jump over to composite view, how to render the fire so that its alpha channel is correct. So we'll go into a little bit of compositing as well as the geometry nodes that we're going to need to create to get our fire simulation. So these are the nodes, and we'll go one by one. We'll create it, and I'll explain as we go what each one does. So let's jump right into it. I'm going to create a new file, not save the changes I just made. We got our blank Houdini file here. I'm going to add a geometry node. I'm going to jump into the geometry node. I'm going to be using forces to create the birth surface area for our fire. I'm going to make 3 of them, but I'm only going to use 1 torus node, and the way I'll make the other 2 will be to drop 2 transform nodes down. I'm just going to copy and paste that. Now we have 2 transform nodes. I'm going to translate it by something like 1.3 and just push the other one in the opposite direction. And then I'm going to merge the 3 together so we can actually view it, and because we'll need them merged. So let's push the 3 together and view that. Now let's back it up and take a look at our toruses. That's looking pretty good. The next thing we're going to want is, now that we have our geometry that we're going to be birthing the fire from, we're going to need to create 4 attributes: velocity, burn, temperature, and density. So to start creating those, the first one we're going to do is velocity. And that's the only one that doesn't use a pyro source. And the way we're going to create velocity, I saw a YouTube video that did this, and I thought it was pretty cool. And it works pretty well. We're going to use a mountain node on our toruses. With that amplitude is fine at this scale. And then for offset, we are going to do something like the current frame divided by number like 15, which will just make it change a little slower. Now you can see as you scrub, the toruses will wiggle, which is exactly what we want. We're going to drop a trail node down, and we'll use this trail node to compute the velocity of our points using compute velocity and central difference. Now if I view the trail node and turn on the velocity trails, you can see them coming off certain vertices, which is what we want. The velocity is a little small for me, so I'm going to actually bump it using an attribute wrangle node. This will be the only bit of coding that we do, but it's one line and very simple. I'm going to go add v equals. And so add v is the velocity of each point equals at v times 5. And that is it. And we've just scaled up the velocity at each point by 5. So now if I view that attribute wrangle, you'll see the traces, I believe they're called. No, they're called trails. You'll see the trails have gotten longer, which is awesome. Now we're done with velocity. We're going to move on to the other 3 attributes, and creating them is a lot easier. All we're going to need is a pyro source, if I spell it right. Pyro source. And I'm going to drop it in, and I'm going to click the pyro source, and I'm going to initialize a burn and a smoke. And so that'll create our 3 attributes that we need: burn, temperature, and density. So now if you can view this, and the other thing I'm going to do is I'm going to surface scatter it, make it a little more random. If I middle mouse button on this, you'll see we have the 4 attributes that we need: burn, density, temperature, and velocity. So that is awesome. We're going to randomize everything but velocity using attribute randomize nodes. So if I type in random, this is the easiest way to find it. And I'm going to drag that in. I'm going to randomize burn. I'm just going to copy that process for my other 2. So temperature, And last but not least, awesome, density. Now we've randomized our 3 attributes between 0 and 1. Last thing we need is a volume rasterize attributes, and that'll convert our point attributes to, whoops, I didn't mean to click into it, to volume attributes that the solver can actually use. So let me just go in here and select all the attributes that we want to perform this function on. So it's our 4 attributes. And now if I view this, you'll see we have these cloud looking things, which is exactly what we want. It shows us that we have these attributes as volumes. Now I'm going to drop in the very new geometry pyro solver. So we don't even need to create a DOP network anymore to simulate fire, because within this pyro solver node in geometry, you have a DOP network created for you already with a lot of presets and a lot of switches. So it does a lot of the work for you, and that's pretty cool. So you can just drag your volume rasterize into the pyro solver. We'll view the pyro solver. You'll see that it now turns into something that looks like fire. That is awesome. If I hit play, you'll see it is scaling with the fire. And that is because this pyro solver by default uses the sparse simulation type, which will cache your fire. We're going to be rendering out a single still frame of the fire, so there's a much faster way to do that, and that is to use minimal OpenCL, which will not cache your fire, but it will run super quickly. So that's fine, that works for us. So we're changing that to minimal OpenCL. Next thing we need to do is do a few things. We are going to go to sourcing, and by default we have 4, and that's good because this is density, temperature, burn to flame, and velocity. We actually need a 5th one that it doesn't add by default, and this will just make our flames work a little better, and that is burn to divergence. As you can see, it works, if I spell it right, it works without this, but I recommend doing it. Now we have our 4 fields mapped correctly. The next thing we're going to want to do is adjust our sourcing. So this adjusts how on how many frames this volume rasterize pushes this data into our solver. You'll see as it is right now, it only runs to frame 12, so you get a little puff of fire and then it disappears. That's not what we want. We want continuous flame so we can get a nice snapshot. I'm going to bump that up to 100. I'm also going to adjust the bounding box, because now that we're using minimal OpenCL, it creates a bounding box and does not scale with our fire. But to create our bounding box is pretty straightforward. We're just going to do 5, and I'm actually going to turn on the template of the mountain toruses so we can get a better view. We can create a nicer bounding box. So I'm going to go to 5. Oops. I can stop double clicking. My mouse has been doing this thing where it double clicks recently, and that is driving me crazy. But we'll do 5, 2, 5, 5, and 2. And if you actually want to see your bounding box, just restart the simulation. It'll take a second to update because we've made some changes. Now you'll see that our bounding box has changed. We want to move the toruses to the bottom of the bounding box. You can move the toruses or you can move the bounding box. I'm going to move the bounding box to up 2. So back up, and now you'll see that they're at the bottom. So that is awesome. And now if I hit play, you'll see we get our little fire simulation. It's continuously birthing fire. And we could take any of these. You see you can't scrub because we don't have anything cached, but you can take any of these frames and create your still image. So what I'm going to do right now This feels like a good moment to create our camera. So I'm going to go in here, I'm going to control click the camera, it'll create it where we're looking, and I'm going to head into view, and I'm going to make my image a power of 2 image. So I'm going to do 1024 by 1024. You can make your render anything you want. And so for our render, we have 1024 by 1024. If I click Alt, I can drag this around. I have lock on, so our camera will move with us right now. For my render purposes, I'm not going to want to render the... Okay, so but here, if you middle mouse button... Oh no, it works fine. Okay, I was going to say it moves the fire around. You got to be a little careful with lock and how you're clicking. You need to hold Alt to get this moving functionality. If you don't hold Alt, what it's expecting is you to adjust the camera using these widgets, but I'm not going to do that. So I'm going to click Alt, and I'm going to zoom in a little bit. I'm going to make it so we don't see our toruses, so we're really looking at just the top of the fire. Because if you look at your toruses, they'll just be super, super saturated with fire. I'm going to look at something like that. It's super blurry, which is not what we want. Now I can unclick that and now head back into geometry. And if I hit escape, sometimes it goes into some weird modes when you have things selected. But now if I hit escape, I'm out of the camera view. So we can look at our fire again. So now what we're going to want to do is adjust our fire settings. We have our simulation running. We have a camera looking at it, which is awesome, but our fire looks absolutely terrible. Let's jump right in. So sourcing is good. We don't have any collisions because we have nothing that the fire is coming into contact with. So getting into the first 2 tabs where you're going to make the biggest differences. Actually, sorry, the first tab is setup, where we can change the voxel size. And we'll do that real quickly, just because right now we have 50,000, which is nothing. So I halved it, which will bump the voxels by an exponential number. And we're going to do this before we adjust fields and shapes to a middle extent. We're going to shoot for something like 2 million voxels, just so that when we adjust fields and shapes, we have a better feel for what our final flame actually looks like. If I hit play, take a look. All right, 2.8, that's perfect for me. So now you can see there's a ton more detail in the flame, which is awesome. And this will be not the voxel size that we're going to render in. It'll be a good one to start adjusting the shape of our fire. The first tab that you're really going to dive into is the fields tab. So you have density and temperature and flame, and we don't have color. We do have speed, so I'll check speed. That was the velocity we inputted. And we're not going to go through field guides. It's a little more advanced, but if we go into density and temperature, something we'll want to check is emit density from flame and emit temperature from flame. That'll basically cause our fire to look a little more realistic. And then your flame lifespan is how tall you want your flames to be. I'm going to back this down just to show you what it looks like. So now we've backed it down quite a bit, and our fire is quite a bit shorter than it was before. And this is, without jumping into our shapes, you'll see that we don't have disturbance, turbulence, shredding. We don't have any of them on, but our fire has a ton of awesome detail. And that's because our velocity is using the mountain, and we have randomized these input attributes. So even without any of this post-processing, I guess you could call it, that the solver does, we have some nice, we don't have mushroom cloud fire. We have some nice detail in our fire. So this might be as far as you want to take your fire, in which case you're good to go, and you can just skip this next little bit where we're going to dive into shape. But if you want even more detail, we can start turning these on. This will up your time it takes to process, but not drastically. So I'm going to turn on disturbance, turbulence, and shredding. Flame expansion is something you're going to want if you have an explosion. But since we're using a constant fire, we're going to keep that off. I'm going to bump the disturbance up. I'm going to bump the turbulence up. I am going to lower the swirl size just a bit. And we'll keep the shredding as it is for now. Let's take another look at the fire. And you'll see it, it's hard to really tell the difference because it already had a lot of turbulence looking stuff from the default, but this is all playing around with your personal preference and how you want your fire to look. So, I think that looks pretty cool. This fire is looking pretty neat. Got some awesome detail in here with differences in density and flame. So that's pretty cool. We're going to stop messing around with these shapes for now. So we're pretty much done with our fire simulation. So that is awesome. The next step is we are going to make this pyro solver something that you can actually render, which is not the case currently. So to do that, the first step is convert it to a VDB. This will make it a lot faster to render. Let's drag that in there. And then the real meat and potatoes of rendering it is a pyro bake volume. I spelled pyro incorrectly. Let's back that up. Pyro bake volume. And this will create a volume. So if we view this, currently it's there's no fire because by default fire is turned off and smoke is turned on. We're going to turn fire on, and it's like super bright. We're going to turn the intensity down a lot. I will, like I said, this is smokeless fire, so I will turn the smoke off in our viewport so we get a good feel for what we're looking at. So all we have activated is fire, which is fine, but there's a lot more you can do here with scatter and secondary fire to make your fire look differently. So a lot of stuff you can do there, but we're not gonna dive into that. I'm gonna go to render view mode, and I'm gonna render out one of these shots. And you'll see this is our fire as it is currently, which goes up way too high, but we're gonna adjust kind of where the highlight is of this fire. But this could be what you want, you could want a full picture, but if you do want a hard stop at the top, you're gonna want to adjust this a little bit. But the place we're gonna adjust this is in the pyro shader itself. And in order to make it so that this doesn't affect your render, you go to here and break material references. So now when we go in here and we adjust this pyro shader, I was like, why is it all blacked out? But that's because we needed to go up a little bit. So now we can adjust this pyro shader, and this will adjust our rendered view. So I'm going to stop rendering this for a second just because it'll continuously render every time you make a change. All right, so we'll stick with that. It's good enough for our purposes, good enough for this video. And we'll just move ahead to the next step, which is also a little unintuitive for new people. And that's if I go in here and I click save frame, which we'll do. But another way you can do this is you could render to mplay. or you can do it from the render view, but that is the same. If we click Save Frame, we're going to get these options, and we want a PNG, which will have an alpha channel. But down here, we'll have, for our alpha channel, a few different options. If we click C, we'll have a totally blank image. If we click Op ID, we'll have a good alpha channel where this is totally black, but where it's gray, it'll basically have an alpha of 1. This is what we'll pick for our purposes, but we're going to have to do some compositing to get a correct alpha. And finally, if you do prime ID, it's the same as doing color. By results, you get just a blank alpha channel, which is not what we want. So I'm going to go into Op ID. Probably going to cut this video just based off where I saved this. But once I have it saved, we'll jump back. All right, so I've listed it as fire example. I'm going to go ahead and save that. It'll tell me that it has been saved. You can go ahead and click OK. And so now what we're going to want to do is jump over to composite view. So what you do is you go to image, which is currently blank, but this is where we'll be doing our compositing. You can just right click, and there's only one thing that you can drop into here, and that is an image network. And this is where you'll do your compositing. So you can click into here, and now you'll get all your options for how to composite. We'll go in here, we'll pick file. It'll show us our current image. So we didn't really mess with the red and green channels, but you'll see that the alpha is all messed up. So, you know, it's all hit and miss with this alpha value of what you're going to get from your fire. And so just because of the settings I've had, you know, you can get anything from nothing everywhere. This alpha value is 1 everywhere, which is also useless. Or you can get tidbits of your fire that doesn't really match up with your fire image. So your alpha will be all over the place just because of how fire has alpha set in Houdini. But it's super easy to get your alpha to look like your image, and that's what you want. And to do that, you just do a channel copy node, and you drag your image into your channel copy node, and then you target your alpha and you source it from your color. And just like that, if I make this the viewed node, and I go to alpha, you'll see my alpha is now the same as my color, which is awesome, which means I can go and save this. And I'm going to save this as fire final. And you need to have pre-multiplied check. You uncheck it, your fire will look grayer. And if you want it to be this white color, just check pre-multiply. For color, make sure color is selected. For alpha, make sure alpha is selected. And you can go ahead and hit save. And just as proof, I'll pull this up in Sprite so you can see what our final image was. All right, so here's our final image. And you can see that we have a nice transparent background and white fire. I can just drop in another layer of black, and I'll just paste it to the back so you can see that this is truly the same as it was. This isn't a great fire render because I didn't really spend a lot of time with the settings because I wanted to make this video short and concise. You see that down here, you know, you have no detail in your fire. It's all white. There's a lot you can do with the settings to make this better, but I wanted to go through the process of each step for those out there who, you know, need a short, concise, and complete tutorial on how to go through all the steps you need. So I hope you found this video to be exactly that. Thanks so much for watching, and have a great day.